So Daniel from 10gen. And 10gen make MongoDB.
They do.
And Daniel's job is to promote the adoption of MongoDB in the UK and EMEA.
Yes, something like that. I'd like to talk to you about what we're seeing in financial services around big data, what we're seeing in financial services around our product, which kind of gives some background to that as well. As I say, my name's Daniel Roberts. I work for 10gen. I joined about 12 months ago, and I'm actually a recovering Oracle employee. After 11 years working for a company where we've got large relational databases, I kind of decided to disappear from a large organization with hundreds of thousands of employees and go and work for a small startup. Actually, it wasn't that small. When I started, it was about 65 people. Today, we're about 180. But we had essentially no one here in London a year ago. So 10gen is the company behind MongoDB. What's MongoDB, I hear you say? We'll talk about that in a minute. We are essentially a NoSQL database. We're around 180 employees now globally. And we've got a shed load of customers, which is really good for a startup. And we're venture capital funded by quite a number of big names in the VC space. So Sequoia Capital, you might know about, a company that has funded the likes of Google and Cisco and a whole host of others. We've also had some funding from some companies like Red Hat and Intel as well. And we're a startup actually based out of New York, so Silicon Alley. We've also got offices in Palo Alto, Silicon Valley, London, Silicon Roundabout. It's not quite so good, is it? So just around the corner here. And we've also got offices in Dublin and Sydney. And so basically, we've been building this open source database which solves a number of problems which traditionally we've had within the relational world. And we've got, this is just a small group of customers which we have right now. And the interesting thing about these customers is that they span pretty much all markets and even some finance ones, as we can see down the bottom here. As you probably appreciate, financial organizations tend not to shout about what they're doing unless they're in the pub, in which case they all talk to one another and they know precisely what each other of them are doing. But we see we span all those industries there. When I first started at a startup, a kind of new database startup, I thought that traditionally we'd be working a lot in very small web-based organizations. But actually the reality is we're starting to see a lot of these enterprise organizations leveraging our software. And one of the other interesting things about 10gen is we try and build community around the world. So we've got literally thousands of individual MongoDB user groups around the world, in New York and here in London and Dublin and other places across the rest of mainland Europe. And so we have nurture a real community of help between different organizations. So even in our office just around the corner in Old Street, every couple of weeks we open the doors and allow people to come in, talk about their problems, share, occasionally talk about technology in MongoDB, and just generally help and nurture the community around our technology. And it's had great traction. It's been very interesting. So what are the challenges are we seeing, and what are the challenges which we're solving? And what I'm going to do, once we've talked about that, what I want to look at is what we're seeing in financial services, and especially in capital markets today, but also what we're seeing for big data in, say, insurance or in retail banking, other things which I want to explore. And also, I think I'm just going to touch on and talk a little bit about how we're seeing big data leveraged in other industries as well, because I think that's really relevant for some of the opportunities which we might see within financial services. So, relational database challenges. What is the problem with relational databases? That's kind of what we're here trying to solve. And I guess that's coupled with the notion of big data challenges. How do you deal with literally petabytes or hundreds of terabytes of data about your customers or about what's going on the internet or about who's accessing your website, about or where location of people are. How do we solve all that? And traditionally what we're seeing is, or what we've been seeing over the last couple of years or so, is that traditional databases for storing big data have started to struggle. And so a lot of our customers that we talk to are saying we have a current system, and because of the market we're in, our data volumes are increasing in size, and we're finding it difficult for our databases to maintain and keep up with what's going on. And so typically, relational databases have these kind of characteristics. They're very structured in nature, so we store data in like spreadsheet-like tables. And every time we want to make some changes, we need to go back and rechange that. So there's this notion of agility. So how quickly can we build? Quickly can we build our data? We've had new data types. So we don't just always store structured data. We've kind of got video data, or we've got semi-structured data and free-form text, and data from mobile devices, or data from other sources which we want to be able to store. And this has kind of just grown in huge volumes. So those relational databases, by their very nature, are difficult to scale out horizontally, difficult to provide performance, and typically are not working that well in the kind of commodity infrastructure which we're now seeing within IT. So what's the solution to this problem? Well, MongoDB actually was actually first thought of by a guy called Dwight Merriman and a colleague of his, a guy called Elliot Horowitz, who are now our CEO and CTO. And their background was from DoubleClick. Have you heard of DoubleClick? The ad serving network. And their startup back in the 90s, they started serving a few ads a day and then a few thousand ads a day. And then ultimately they got up to about 14 billion adverts which they served per day. And a lot of their engineering effort within their organization, trying to build systems to support this, was all around trying to scale out a database which would deal with this big data and this big volume which is being driven through it. And so MongoDB is really designed to fix some of those issues. It's designed to fix them by being agile, being much easier to develop software against in the first instance, being scalable. Traditionally, relational databases, when you scale them, when you start running out of performance, you buy a bigger server, and then you buy a bigger server, and a bigger one, and you buy a huge, great server, which costs millions of pounds, which, of course, Oracle loves. But you don't love quite so much, especially when you're a startup, when you want to start things generally smaller. So lower cost is always good, and lower cost when it's open source. So the database notion that we created is what we call a document-orientated database, which means it maps much more cleanly onto how we think about how we store data in the real world, or how we think about things. And so traditionally in a relational database, we have all these rigid structures of data. But in MongoDB, we actually store things as objects or documents. So they're much more closely related to the relationships of data that we typically talk about. So relational database is big, structure, brittle. Every time I need to make a change, I need to go back to my database and change things. MongoDB, so it's much more object-focused, and we can just store that data relatively easily. So that's good. So ultimately, though, we kind of end up building out this huge, great architecture of databases, of MongoDB instances. And this is what we call a sharded cluster. So rather than in a relational database, we have a big server. With MongoDB, what we do is we take that data and we have what we call a shard, which is just a partition of data. When we run out of performance on that or run out of resources on that server, we split the data more and more and more, and we scale it out horizontally from not just having one server, one expensive large server, but essentially we have potentially hundreds of cheap servers, which you can just, when you run out of resources, I can just create a new one, and I can just plug it in and continually to grow out. And so this kind of architecture of software was traditionally very difficult with the relational world. And so with NoSQL databases and MongoDB, we can actually scale that out increasingly and deal with these huge big data problems which we're seeing. So relational world, difficult to scale out. MongoDB, it's much easier to create. And this kind of gives us some opportunities to solve some problems within financial services, and also gives us new interesting opportunities to deal with, to leverage. So, financial services, what are we seeing right now, and how are people using our technology, and what are the kind of problems which we're solving? So financial services, I guess the people that tend to move first within financial services are guys in capital markets. They tend to probably take more risks with technology and play with the technology a bit more earlier on. So typically we see things like high volume data feeds. We're taking ticks. We're taking financial information or orders in the format in what we call fixed messages, as an example. So we see people taking that kind of data, storing it in MongoDB. Huge throughput, many tens of thousands or hundreds of thousands of messages per second. We see it in risk reporting and analytics. So, for instance, I might have an organization and an investment bankers, and say we might have lots of different front office organizations. We might want to be able to aggregate the risk to maybe take a view of counterparty risk across the whole bank. So we see that kind of use case, and we've got customers here in London who have production systems on our software doing counterparty risk across front office systems. So we see that. Product catalogs and trade capture, so actually capturing information about trades and things which are happening. Each time we have a number of customers that are building trade stores for regulatory compliance reasons. We want to store our trades for the last 7 years. It's quite a lot of data every time they change. And then we want to be able to query it at any point in time so we can take a specific view of what we knew at that particular point in time. So things driven like greater transparency, data volumes have increased because of things like Dodd-Frank. Other things we can just pick out here and talk about, quantitative analysis and automated trading. So buy-side firms, we're seeing MongoDB used there. Athena Capital was one I talked about earlier on. Another one for tick data is Daiwa Securities. There are a couple I can talk about publicly. And reference data management, as an example. That's a big problem which we've seen. Large volumes of data which change a lot, but need to be globally replicated. We've got one investment bank based here in New York and London that are building out a reference data platform. Previously, they had like 90 globally dispersed relational databases all integrated together individually. They kind of migrated off that, or in the process of migrating out of that into MongoDB, which allows them to save a lot of money, actually. Which is always good. So lots of use cases there around capital markets. More are coming on stream every day. We're having lots of conversations in that space. But one of the things I wanted to talk about, as I said, is what are other industries doing? In capital markets, it's quite specific, the use cases that they're trying to solve. What can we do about the data we gather? What can we learn from other industries and the data they're gathering? And I guess one of the really frightening industries, who knows quite a lot about you, is the telco industry. So they all know you're here tonight. Did you know that? Because you've got your mobile phone in your pocket. They know where you're browsing. They record where you're browsing. They know who you're SMSing to. They know when you're walking down Oxford Street. They know where you live, what your age is. They may even know your inside leg measurement, but I'm not sure how they'd know that. And so these guys are actually, one of our partners is actually working with a telco here in London, and they're measuring footfall. And the first time I heard this, I thought, footfall, what does that mean? And it actually means that they can tell their customers, their internal business customers, how many 16 to 24-year-old females were walking down Oxford Street on Saturday afternoon, and which websites they were browsing, and how you might want to target them more effectively. And so that kind of data is what some of these guys are gathering. And gathering that data is literally hundreds of gigabytes or terabytes of data on a daily basis, which they then store, process, aggregate, and then churn out with some kind of interesting insight. And so if you think about a mobile phone and the data they have, it's really interesting. Now let's think about, well, we could couple that against NFC for payments, or maybe some mobile payment services. It's kind of interesting use cases. So we've talked about telcos doing exciting things there. If you think what supermarkets are doing, they've always had loads of data. There's the story about the supermarket in the US who could tell when a woman was pregnant before her husband knew, which was also interesting. And so supermarkets have leveraged their data quite successfully, and they've actually moved into financial services. So we've got Sainsbury's Bank, Tesco's Bank, and all those other kind of use cases. the question I have is, when are the telcos going to move into financial services? So all of a sudden, we're seeing these external companies gathering data and starting to move into the financial services space. When's the first bank going to move into telco? Or when are we going to see O2 Bank, as an example? And so financial services institutions actually probably know even more about us than the telcos, because they actually know whether you spent money in H&M on Oxford Street, rather than the telcos just speculating because you were walking up and down outside the door. So we kind of need to gather, I think certainly within retail banking, we could perhaps leverage interesting information there. Of course, in the telcos, this has to be anonymized and cleaned and cleansed because of privacy laws. And no doubt the same needs to happen in financial services. We could then tackle that with geolocation data for things like pay-as-you-drive insurance. We're seeing that already. But what about kind of data from mobile web apps like Foursquare? Anyone use Foursquare? No. Oh, one. It uses MongoDB, by the way. So Foursquare, you check in, you tell it where your location is. It would be really interesting to couple with logistics about where you're at, which couple with payment and phone devices. Fitbit. Has anyone heard of Fitbit? It's a little thing you stick in your pocket. They're gathering information about your health. Do you sit on your backside all day long in the office, or do you run around? Hey, pay-as-you-go health insurance, right? They know who's the fit ones and who aren't the fit ones. They even have a scales which you can stand on and measure your body fat. That's kind of concerning. So there's a great opportunity here, I think, which we're not leveraging really within insurance and certainly within retail, about the data we're gathering and how we can utilize that. And I think there's a huge, great opportunity for us to kind of leverage in that some way. So kind of just to sum up, we kind of got this convergence of all these people gathering similar data, location, habits, shopping habits, where we're browsing, what we're doing. And the opportunity for us is to try and figure out how we can leverage that from a financial services perspective. Can we drive it from a retail banking or an insurance perspective to kind of have new innovative products? And I think some of the products which we've got, I'd like to say MongoDB, of course, but some of those big data products where we can store lots of data gives us the opportunity to try and figure out and infer interesting things and maybe infer some new exciting use cases. The key thing for us is how we monetize that and provide useful services, of course. So, summary, what's MongoDB? It's a document-oriented database. It's cost-effective. It scales massively with all that data you're going to query. And really, it's great for analytics, and the new possibilities of being tying those two things together, I think, are something which we really need to think about. OK, have I gone over?
Questions for Daniel, please.
So I get it that the MongoDB is the place to start with the scalable things and all. Good one. But what about the systems which are already there on the traditional style RDBMS kind of systems, as in MySQL, Oracle and all? So do we have any kind of a migration thing with MongoDB?
Yeah, so it's very it's usually when we talk to customers that they're either building new things or they're migrating from existing systems. So MongoDB stores data in a very different way from relational databases. So there is a notion that we need to migrate all that data. So that's something which needs to be considered. But yeah, people are migrating data from those systems into relational and non-relational databases.
But there is no, as in established support provided by MongoDB, that the guys need to actually crunch the code.
You can't just press a button and all your relational data goes into MongoDB or any other non-relational database. And that's because the structure is so very, very different. They store data in a very different way. There's kind of a slightly different, totally different structure and different way of thinking about storing data, which gives us the ability to provide that massive scale, which has traditionally been difficult within a relational database.
Thank you.
Thinking about the middle layers that you're going to put on top of MongoDB and build your application on, what works really well or what's quite exciting for us to start using?
For what you're actually building your application in. Pretty much anything you like, to be honest. The nice thing about MongoDB as a database technology is very close to a lot of different application programming languages. So things like whether it's Ruby on Rails or Java or Python, they're languages where you build objects and store objects, and we essentially store our data in an object format. So that kind of impedance mismatch between an object application, which is what people build applications in, and the relational database is kind of tends to melt away. And so it's actually much cleaner, I think. So if your favorite language of choice is Ruby on Rails or Grails or something else, or Python or JavaScript or Node.js, that's fine. We work with all of those.
And any particularly powerful sort of middleware?
Powerful middleware, well, I guess if you're looking, any middleware you like, I think. So if you're from the Java space, using Java Enterprise Edition, messaging technologies, then we've seen them all. So if you're in an enterprise right now and you've got an Oracle middleware platform, then we're perfectly happy to use our Java technology to connect to MongoDB in that particular space. If you're more web focused around, say, Python or Node.js, then that's great too. So we're pretty agnostic to whatever your middle tier is. We support, about 12 drivers, I think. But the community supports, dozens and dozens more. So from R, statistical packages like R, all the way through to Erlang, or actually no, I think we support Erlang, through to some other bizarre language.
So you talked about scale out, and in terms of scale out, what's the largest deployment you have compared? Because Cassandra figures are pretty much like the largest one is over 300 terabytes of data set. So what is your largest deployment, and how does the performance actually go on the writes and reads? And also, when the data set grows, then the performance actually has an impact. And with a large data set, how does that actually work?
Sure. So if we're going to look at pure sizes, we have data sets in the kind of 1, 2, 3 petabytes size. So much more than terabytes, hundreds of terabytes, thousands of terabytes in size. So the architecture is what we call horizontal scalability. So that if I have a single server that'd be able to provide, say, 50,000 updates a second or 50,000 writes a second, then my application can be split. The data, as it grows, can be split across identical, what we call shards. Continue scaling out that way. So so the performance of a single shard, a single set partition of data, should be the same whether you've got 1 or whether you've got 20, 30, 50. And so we've got customers that have got 260 plus, in fact here in Europe, 260 plus shards of data, each maintaining their own partition and their own performance. So as the data scales, the whole notion about it is that we provide linear scalability and performance. So assuming that your application is designed well and great, then as you scale out, then you should be able to provide pretty reasonable linear performance and little degradation in response times.
Just looking back at the capital markets slide, I think if I look back 10 years and we think about the relational space losing kind of market share to KDB and Vertica and the columnar kind of databases, and I'm interested to see that you've got tick data and time series up there.
Yeah.
And I guess that the indexing on a Mongo sharded instance in terms of time indexing, because I don't know how it indexes. Are people moving to Mongo for these non-object databases as much on cost, or is it a performance thing?
So I think
because KDB is very expensive, obviously.
So I think it surprised us as well that people have moved down the line and implemented tick data solutions on MongoDB. Absolutely, based around cost, because some of the cost in OpenTick or OneTick or one of those others tends to be, they tend to find it expensive, or they don't quite like working well with it. So really, we kind of they use it for a number of reasons. One, it's simple. The actual data model programming, if you're a software developer, it's really simple to develop against MongoDB. If I can just store some data, I don't need to tell MongoDB ahead of time this is the shape of data I'm going to have. So it's really nice to develop against. So that kind of draws a lot of people to use it. The fact that the performance can be really quite fast. is also another thing. So we can take, literally, tens of thousands of inserts per second per shard. We've got a customer doing circa 2 million updates and inserts a second on their sharded cluster, so pretty reasonable performance. And yeah, the object model, the object model just maps so much more cleanly to the data, to the application code. The other reason they like it is that MongoDB's got built into it the ability for you to crunch and aggregate data. And I won't go into the mechanism, but we've got a thing called the aggregation framework. So I can push in tick data as an example, and then I can shape it with the aggregation framework into candlestick charts or whatever, some other shape. So I can take ticks in coming in many times a second, and then I can say this is what the shape of that data is with a high-low close price over the last minute or 2 minutes or whatever it could be. So there's a lot of, it's not just the storage of data, it's how we can shape and manipulate that data as well, and how we can query that data and infer interesting things out of it.
What about security issues such as record locking, encryption, compartmentalization of data, and so on and so forth? In what I'm doing, I need to have an extremely high level of security.
So security is at a number of levels. Basically, right now, it's at we provide authentication at a fairly basic level within your database. If you want cryptography and confidentiality of your data, right now that has to be at your application level. So what we have people in their applications encrypting data and then storing that data directly within the database. So I've got to be fair, it's pretty light right now in the current release. In the next release, software vendors, it's always the next release. But in the 2.4 release, which is coming out next month, then we'll provide support for Kerberos authentication. We'll have support for LDAP authentication as well. We will ultimately have fine-grained authorization across the documents we store. We have SSL security between all the nodes, and we are now working to look at PKI authentication as well onto a particular document for finer level authentication and authorization. So there are a number of levels. Certainly the earlier versions of MongoDB were, it's up to your environment or your application to sandbox that. But I think as we've moved into capital markets and as we've moved into the large enterprise, our new enterprise customers are demanding these features. So there's audit capabilities coming into the product. There's authentication, finer-grained authorization, and all those things are coming on tap into the product over the coming releases. So yeah, it's not there now, but it's a real focus for us.
Yes. I've read I think on MongoDB site that Mongo is supporting spatial queries, meaning vectorial queries. And I think it may interest a lot of people to know how it is done, if it's only two-dimensional, if it works well with the sharding. And, that's the main question, I think, and if it's on the plan for later, if it's not actual. So 2D queries. Yes, there are a lot of geospatial query capabilities within MongoDB. So, for instance, as we saw back on some of the customer slides, O2 is a customer of ours, and they have a product called product called Priority Moments. So basically, when you're walking down the street and you walk past a shop, they can go ding. We'll send him an advert. We'll SMS him a token, and that's all based around geospatial queries and about the location of your phone being sent, the geolocation of your phone being sent, and saying, give me all the offers within this particular location, or within this box, or within this polygon area, or within this postcode, to allow you to query that data based on your location. And in fact, we're seeing the same thing with telematics companies as well that are coming on stream and using MongoDB to say that, as their trucks, when's my truck traveling down the motorway? Is my driver doing the right speed? Is it too fast? Has he stopped? Why has he stopped? Oh, the door's opened. Oh, and when did the engine switch on and off? So all those kind of things are tied in with geospatial queries for storing that. We also have geospatial queries now as part of what we call our aggregation framework. So we can kind of crunch data based on location. So I can have a document and I can just choose different values out of it and add them up based on a particular geolocation query. And from a sharded perspective as well, sharding is quite difficult on 2 dimensions. The 2-dimensional queries
that we support. There is some work done on. I'm not quite sure where we're at in the product on that right now. There is some work being done on it. There are certain ways you can shard on geospatial queries. You tend to just shard on one value, and then you essentially stripe the Earth, which allows you to partition your data across lots of different areas. So that's coming on stream. That's interesting stuff. The geospatial queries. Foursquare is the other one that uses geospatial queries, and we've got various other ad-serving mobile-based applications that are using geospatial stuff to kind of pinpoint what's in your area. There's also some calculations within MongoDB, because clearly the globe is not flat. It's kind of spherical, so it'll take into account things like spherical and slightly different shaped squares, as it were. So all interesting stuff. Yeah. Does that answer your question?
Great, thanks. Daniel Tengen, thank you very much.
Thank you.